Hello guys, welcome back to this channel. Today we're gonna be learning Python. Python is really a great language if you wanna get involved into web development, server end development, building games, machine learning, data science, and artificial intelligence. Okay, yeah. So probably you're here because you already made up your mind. But for the people who don't know what Python can really do, that's some of the stuff that you wanna do. Okay, so before you get started with developing with Python, you need to install Python on your machine. So be it a Mac, Unix, or Windows computer. Okay. Now to download Python, you just have to go to this website, python.org. Okay, and once here you can click downloads, and what the website will do, it will automatically detect the Windows version or the Mac OS that you're using, then probably offer you the download button. So right now it's at 3.1.2. So once you click download, it's gonna open up and ask you to download it somewhere. Okay, and once the download is ready, all you have to do is to find it. For example, mine is right here, so I can click and run that setup. Okay, this setup is really very easy. You just have to basically click next, and since I've installed mine already, I'm not gonna go through this again. All right, so yeah, so that's it. So once the Python, I'm gonna close this, so you should not exit. Yes, so once the Python is installed, I would also like to install a code editor or a text editor that we'll be using. For example, in this case, it's called Pycharm. So I want you to search for Pycharm. Okay, and Pycharm is a great text editor for Python, and we're going to be using it later in the tutorial. So I'm going to click here on download Pycharm, and I'm going to show you the Pycharm version that I use and that you can also download, because I have a paid version and a free one, but I personally use a free one. Okay, so there's Pycharm for professional developers, then they have Pycharm for the community edition. Okay, so you can hit download, yeah, and it open up also somewhere you can download, but I already have it installed. Yeah, so I'm not gonna be downloading this. Okay, but once you set it up, it's gonna give you an interface that looks like this. Okay, yeah. So now basically for these first few sessions of the tutorial, we're gonna be using what's called the Python idle. Okay, so once you go to the start menu, for example, I'm using Windows for this tutorial, then all apps. Okay, if I'm to scroll down and find Python, I'm gonna find a couple of modules installed. Okay, so what I'm gonna open up is this idle. Okay, it's a good way to start off writing Python code and testing out basic arithmetic like computations. Okay, so if your fonts are too small, probably you can go to options, then go to configure idle, and where there is 16, because right now I'm using 14. Let me see, 14. You can turn it to 20 to make the font sizes bigger or smaller, but for this tutorial I think I can increase it to something like 25. Let me apply this so that everything is visible, or even much more than that. I could go to 29. Yeah, all right. So to test out whether everything is working well, all I have to do is to give it some basic arithmetic computation like 4 plus 6, and it should return 10. Yeah, 3 times 4, yeah, it's gonna return 12. Okay, so now let's proceed on to the next module of the course, where we talk about numbers. So now guys, I want to show you or teach you something about the numbers and the arithmetic operators, then we can move on to variables. Okay, now when you're in your idle right here, you can say stuff like, as I've just shown you, the 3 plus 4 is equal to 7. That is basically addition. Then 4 minus 5, that is a negative 1. 5 divided by 3, that's 1.66. Then you can have 5 multiplied by 3, by 3, that is 15. And there is another, let me show you something, another division kind of arithmetic operator in Python, something like this, that sort of rounds off the division of 5 by 3 to the nearest whole number, okay, to the floor whole number, okay. Now, for example, 5 divided by 3 is 1.6. So what this does, it divides 5 by 3, then rounds it down to the nearest whole number, okay. Then you have stuff like modulus, for example, 5, maybe 6 modulus, that's 15, 6 modulus 4. What this has done is basically get 6 divided by 4, then basically take the remainder of 2, which is the one that you're seeing here, okay. Then you have stuff like powers and exponentials. For example, if you wanted to multiply 6 multiply by 6 by 6 multiply by 6 multiply by 6, okay, that would be this figure. Or if you wanted to multiply 3 multiplied by 3 or multiplied by 3, that would be 27. Now to simply do this, we'd say something 3 and to the power of 3. So these two multiplication signs basically give you this result. And when I press enter, for example like this, to show you that this is 27, same result as these, okay. Then all these functions or arithmetic operators that you've seen basically have what's called a precedence, okay. So for example, if you're doing 2 plus 3 times 2, okay, you may get something like 8, but you could have intended for 2 and 3 to be first added first, then multiplied by 2. And to do that, what you'd have to do is to use parentheses. So it's set 2, you add it to 3 first, close them off, then multiply them by 2, then you'll have your figure of 10, okay. So now that we've dealt with the operators, let's look at variables. Now variables, what a variable means is simply a placeholder for a value or an evaluation from an expression, okay. Now let me show you something. For example, if caps, this is how they're declared in Python. You can say caps is equal to 4, okay. And what we can do with this variable is that we can add it up, just the same way we've done these, okay, or multiply them. For example, you can say caps multiplied by 3, then you get something like 12, or you can actually add them. For example, plates, let's say plates, okay, and we are saying it's a value of maybe 6, okay. Then we can say mugs, let's assign it maybe 2, okay. So we can say plates plus mugs, and it's gonna give us an answer of 8. And what this is basically saying is just get the figure of plate 6 and add it to the figure of mugs, which is 2, okay. That makes sense. All right, so now we're gonna be moving on to discussing strings, okay, because some of these arithmetic operators apply to strings, as you're gonna see. So now I want to talk to you guys about strings. And what strings are, they're just basically text, okay. They're just basically text, that's all. And to store text in Python, here's what we do. You start off with a double quotation mark. This tells the program that the string starts from here, so you can store your name, for example Alice, okay. Then the second quotation mark signifies that this is where the string ends, okay. So this is Alice. Once you press enter, there is no error whatsoever, okay. Alternatively, you can use single quotation marks like this, Alice, okay. Then press enter, boom, there are no errors. However, there might be specific times where you have to choose one over the other, okay. Let me show an example. For example, let's say you want to print something out like I don't want to go home, let's say I don't wanna go home. Yeah, and it's basically saying once you press enter, it says invalid syntax. Okay, because it read the string from here. When it made the second quotation mark, yeah, it stopped reading the string and doesn't know what to do with this text. Okay, now to fix that, there are two ways to fix that. First, you can use double quotation marks instead and say something like, I don't wanna go home. Okay, see that off with another double quotation mark, hit enter, and that's all right. Alternatively, what you could do is you can say, I don't wanna go home. Okay, but to fix this, you have to use a backslash. And what this does, it tells the program, okay, just treat this next character as normal text. Yeah, once you press enter, boom, there's no error whatsoever. Okay, then let me show one more example. Probably then we move on to some operators on strings. Let's say you had something like this, where we're gonna type Alice said. Okay, so now we're gonna enclose some double quotation marks of what she said. Awesome, I am awesome, something like that. Then hit enter and that comes out perfectly. Okay, so now what we're going to deal with next is what's called string concatenation. Remember how you guys we performed some addition and subtraction and multiplication for numbers? Now some of those methods really work well with the strings. Okay, for example, let's say we have a name. Let's call it the first name. Alice. I'll say Alice. Okay, leave a space. Then we can say the surname and assign that to something like Jones. Okay, and when you add those two up, for example, first name plus, okay, last name, surname, actually, you get Alice Jones. Yeah, so it's basically taking, this is called string concatenation. It basically takes this text and kind of ties it up with this text to form something like this. Okay, that is really cool. Then one other thing that we can do is that we can, let's say you want to print out the name James 5 times. Okay, James 5 times onto the screen. Probably what you do is to print it out like over 5 times, but a quicker way is to use like multiplication operator like this, then just put a figure how many times you want to print it out. Okay, so it will print out gem 7 times. Okay, yeah, so that's all for string methods and how to store them in variables, add them, concatenate them, and this is called string replication, okay, so now let's move on to some other methods that can be used on strings, and I'm sure you'll find them interesting. So guys, now I want to teach you some cool methods as regards strings. Okay, now let's say we have a student that is called Alice. Okay, Alice Jones, something like that. One thing that I would like to stress out right now is that computers do not count the same way as humans do. Okay, for example, if you wanted to pull out the first the first character or for this name, you do something like this: student, then open up square brackets, and inside these square brackets you'd put the number of the position of the string that you want to pull out. Okay, for example, computers start off from 0 while humans start off from 1. Yeah, so a computer would count this string, for example, 0, 1, third position, fourth position, fifth position. Okay, so if you want to pull out this value right here, then we can insert in 0. Okay, and it should pull out the letter A. Okay, then let's try something like, so I'm gonna copy this. Let's say if we try to pull out to print out the 6th position, then it would get this J. Yeah, so 0, 1, 2, 3, 4, a space, okay, which is 5 spaces are also counted, then the J. Okay, then you can also count backwards. For example, I would say if I paste in student, the -1 indicates the last string. Okay, it can't start from -0 because -0 would still be 0, which would be the first position here. Okay, so it should pull out the S, print out the S. Okay, yeah, something like that. Then there's something that's called slicing. Okay, now the way slicing works is that you can get something like student. Okay, then tell the computer or the program to print out, let's say, from the 3rd character to the 7th. Okay, then you end there. Then you have to print out from the 3rd, which is 0, 1, 2, okay, up to the 7th, which is J. Okay, yeah, so J is 6, but it doesn't print out the 7th. If I wanted to print out, then I would make it the 8th position, something like that. Okay, so I'd copy this maybe and paste it in right here, and I'd include it. Okay, then I'd run the code and to print out Ice Joe. Another way to print out to slice these strings would be, let's say I forget to include something here at the beginning. Basically what the compiler would take this as to start printing from the first position 0, and it will print up to the 8th position. Okay, then also if you forget to, for example, to include the last one, then it would start from this position, which is the 3rd position, but yet it's indicated as 2 towards the end. Okay, yeah, so now one pretty common function that you always find with strings is the length function. Okay, so let's say, for example, you have password, something like let's just type in something like that. Yeah, maybe you wanna count the length of this. So there is an inbuilt function, for example, the way we've been using print. Yeah, there's an inbuilt function called len, which symbolizes length. Okay, that intakes a string, then counts the number of characters that the string has. Yeah, so now I want to test how many characters that my password has. Okay, so my password has 12 characters. Okay, now that is, I think, basically simple, and I think we need to move on to the next section. We are gonna be talking of lists. Okay, so now let's talk about lists. And what a list is basically a collection of items. So it can be a list of food items, can be a list of grades, scores, numbers, letters, a list of your friends. Yeah, now if I'm to give you an example, for example, if I have my list of friends, yeah, so which I'll call friends, yeah, then I'll type in my friends. For example, to insert items in the list, you do square brackets. So lists can contain strings, a mixture of strings. For example, if I have Tom inside here, use a comma to separate that out. I can add 67 like a figure. Then I can add some other stuff like cape, something like that. Yeah, but this is gonna be a list of my friends. Okay, so I'll remove these, then just keep it strictly names, just so it makes more sense. Yeah, so we have Jack, Dora, Let me add one more. Let me see a name that I can use. Maybe Steve is also my friend. Yeah. Okay. So this is declared. Yeah. We've added this to our list is now stored in a variable called friends. And guys, remember how I emphasized that computers start counting from 0. Yeah, position 0, position 1, position 2, position 3. So let's say we want to find out who is the number one name on the list. Okay, we would go to friends, type friends, then use square brackets, then use 0 to find out who is number one on the list. Then we should find out that it's actually Tom. Okay, now let's say we want to replace Jack with another name. Yeah, maybe you type it wrongly and it's Jackson. Okay, so remember this is our position 1, then this is position 2. So what we can do is we can type friends. Okay, then in position 1, okay, we're gonna assign it a new name. Yeah, for example, Jackson. All right, then click the end, then type friends to check the items that are now stored, and you find that Jack has been replaced with Jackson. All right. Okay, one more trick that I would like to show you guys. Let's say now if you want to add more items to the list, for example, if I want to add more friends to the list, what I would do, I would say, I'll type a command like, so just hold on. I just hit enter. Then I'll type something like friends dot append. So we haven't discussed these dot operators, dot append, and these functions. Okay, but very soon I'm going to deal with that. Yeah, so basically what this is telling that get this friends list and do something with it. And what we are going to do is we're going to append, which basically means on top of that list add another item. For example, let's say we want to add Jotham as our friend. Then we print out our friends list. Okay, then we shall see that Tom, Jackson, Dora, Steve, and Jotham. So Jotham has been included on the list. All right. So just as slicing worked in strings, it also works with lists. Okay. So for example, you can slice something like friends, and remember, guys, to slice, the first number you use is the position. For example, let's say we want to print from Jackson to Steve. So Jackson is the second list. The second item on the list. So it use 1, then use this colon up to Steve. So Steve is 0, 1, 2, 3, which is position 3. But I'm gonna use position 4, and it should print Jackson, Dora, Steve. Yeah. So when you're slicing, it stops at it doesn't print out position 4, but it stops on rather position 3. Okay. All right. So you can also remove some items from the list. For example, let's say you wanna remove Steve as our friend. Remember, Steve is position 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay. So what we would do, okay, we would do friends. So telling the computer go to position 4, okay, and remove that. You just change it to an empty string. Okay. Then once you print out your friends list, Steve would be gone. So 0, 1, 2, 3. Oh, Steve is position 3. Yeah. So I think we also need to change that. We instead deleted Jotham. I think you guys get the idea. Yeah, I wanted to remove Steve, but yeah, Steve was position 3. We ended up removing position 4. Yeah, but I think you guys get the idea. Yeah. So now, what if we want to delete the entire list? But before I delete the entire list, let me show you guys how we can replace some of the items in the list in bulk. Okay, for example, let's do something like friends. Let's take a look at our first two items on the friends list. Okay, to do that, we use this colon. Yeah, so remember guys, once you leave this left side empty, basically signifies that we are going to start from 0, then this is the last position. So for example, this, it will print out Tom and Jackson. Okay, so let's say we want to replace Tom and Jackson. I'm going to copy this. Okay, I'm going to copy this and I'll paste it right here. And what I'm going to replace my friends list, these items in the friends list, to something like Mary, and let's say Jane is also my friend, something like that. Yeah, so once you print out the friends list again, it's gonna have Mary, Jane, Dora, Steve, plus this empty guy right here. And yeah, that's just about it. So now we've covered almost some of the major tricks that you can play around with lists. However, one more trick, maybe you want to delete the entire friends list or the items. What you would do is friends, yeah, open up the square brackets, yeah, then use these colons. Remember guys, we said on the left max the start, and if you leave it blank like the way we did, then it's gonna start from 0. And then if you leave also the right side blank, then it's gonna handle up to the entire end of the string. Okay, so once you want to set it empty, you just have to equate it to an empty list, something like that, then you run end. So once you print out friends, you're just gonna have an empty string. Yeah, so now that has been part of the basic fundamentals of Python. We're gonna move on to just a little bit more complex, but I'm gonna explain it in simple ways, just so everyone can track along and understand these concepts. Okay, we are gonna move and start working from Pycharm. Yeah, as you guys can see here. Yeah, we're gonna start working in Pycharm, and no more idle. Yeah, this is really basic for just running simple commands here and there. So catch you in the next tutorial. But guys, please subscribe to the channel if you find this information very very useful. So now guys, I want to talk to you guys about if and if else if statements. But before we go there, we need to create a new project in Pycharm. So open up your Pycharm that you just downloaded. Mine is here open, and create a new project. So click on this hamburger menu, under file, click on new project. Then I'm gonna delete this until the backslash. Then I'm gonna create my project called YouTube Python, something like that. Then I'm gonna hit create. Okay, then it's gonna open up a new project here on the left. Okay, so now it's created the files right here. Okay, and now what I'm gonna do, I'm gonna right click on this and say new Python file. Then I'm gonna name the Python file if statements. Okay, yeah, so now let's get started. What is an if statement? An if statement is basically something that just tests if a given condition is true. Yeah, take an example. If maybe you're organizing a party that is for 16 years and above. Yeah, so someone comes, for example, to the party and their age is 13. Okay, then we could write maybe an if statement, for example, if age, okay, is less, this is greater, is less or equal to 16, yeah, put a colon. Okay, then what do we do if, what does the program do if the age of someone is, let's say, equal to 16? Then you're just basically gonna print out something like you're not allowed, you are not invited for the party, something like that. Okay, let me zoom in here, so hope you guys see these things clearly. Yeah, so now if I'm to save this and run it, so to run the files, you can right click, yeah, then you run this, or you can change this to current file, then hit this play button, which I really think is easy. Okay, so now it checks this age, it says that it's 13 and it's less than 16, so which means this condition right here is true, so it prints out this text right here. Okay, so what if the age, for example, is 23? Okay, then we save that and run it. It doesn't display anything, because if someone's age is greater than 16, then there's no command for that. Yeah, so what we do in this case, what we do is that we write an else statement. Okay, actually it's elif. I'm going to show you where the else statement is used. So when you use the elif, it evaluates this. When it says that it is true, then it prints this out. However, if it's false, then it checks the else if. Okay, so you can say else if age, okay, is greater than 16, is greater or equal to 16. Okay, then what do? We're gonna print out and tell these guys that you're invited. You are invited, something like that. Okay, so we save this up and run it, and it simply says that we are invited. Okay, so maybe let's consider grades. So let's consider grades and see how we can use multiple elif statements, then the else statements. Yeah, so let's say a student scored 85 in a certain exam. Yeah, so you write that if the grade, okay, is greater or equal to let's say 90, then print you scored an A, you got an A, something like that. So I think I'll be reusing this, so let me copy it, and so we're gonna write another elif statement, and we say that if the grade, now we're gonna consider for someone whose grade is greater than 80, who got a B, something like this, then what we're gonna print out is that you got a B. So I'm gonna change this, and for, let's add one more elif statement. So let's say if the grade is greater or equal to 70, okay, then you're gonna print out that the student actually got SC. Yeah, then let's just pull in the else statements. Okay, and what we're gonna do is, for anything, if the student doesn't score above 9, doesn't get a B, an A, or a C, then probably I'm just gonna tell them to work hard. So you need to work harder. You need to work harder, something like that. Okay, so when you save this and you run it, it will automatically tell you that the student scored a B. Okay, let's say they scored 66, then the program is going to tell them that you need to work harder, just like this. Okay, yeah, so I think that was pretty much easier to understand. And let's proceed to using for statements. Welcome back to the channel, guys. We're gonna talk about for loops. Remember how I discussed with you lists in one of the previous tutorials, that the way you would have to deal with lists. For example, if I had a list of friends, let me zoom this in so that you can see clearly. If I had a list of friends, and on this list of friends, I showed you guys that the way to store items in the list by using square brackets, then quotations. So if I had James, that's my friend number 1, then another friend may be Alan, then Ahmed, and lastly maybe Joanna is my friend. Yeah, so I have a list of 4 friends. Yeah, now what a list helps you with, it helps you to save up all these names in a single variable. Yeah, otherwise if you wanted to store them like without lists, then you would probably have to type something like friend1, something like this, maybe friend1, and assign it to James. Okay, then friend2, you guys already see how awesome this is. Yeah, friend2 maybe Alan. Okay, so if you had maybe 1,000 entries, then this really doesn't, it's not so efficient. So if you wanna have friend3, then you'll have Ahmed, something like that. Yeah, this is not efficient at all. Okay, so let's say you wanna print out all these friends of yours, then you'd have to write separate print statements. Okay, so you print friend 1, oh sorry about that, friend 1, then print out friend 2, and so on. Yeah, something like that. So save that up and run it, something like this. But where a for loop comes in, where it comes in so handy, is that it won't need to go through each variable like this if you have a list that's stored like this. Okay, so I'm gonna remove this, then probably I show you guys what you can do with a for loop. Okay, so the for loop, the way the syntax is, you start up with the keyword for. Okay, then you declare a variable, for example x. Yeah, and what this does is that it tells sort of like a placeholder that every time the loop runs, it's a placeholder for this position, which is 0. When the loop runs the second time, then it is changed to position 2. If the loop runs the third time, then it's changed to position 3, something like that. Yeah, so we're saying that for x, yeah, for each item x, yeah, in the list. So what is the name of my list? Friends. Okay, what are you gonna do? Yeah, for each item that we have in our friends list, we are gonna print out x. Okay, and when we save this and run it, then we are just gonna print out all our names at once. Okay, however, you may not only have to print out only one command at this stage. You can do a lot of things. For example, you can find out the length of your friends' names. For example, you can use print, and inside print, we're gonna use inbuilt function of Python called length, but they just call it len. Yeah, then inside len, we're just gonna still pass this variable x. Okay, so when we save this and run it, yeah, so it's gonna run the first time, it prints out James, and James has 5 characters. Then second time it prints out Alan, and Alan has 5 characters also. Then Ahmed also has 5, then John has 6. Okay, pretty simple. Yeah, that's all I had for you for loops. I think you guys have seen how easy they are. Okay, so let's move on to the next module. So now guys, I want to talk to you guys about while loops. And a while loop is kind of different from a for loop in that it tests, it keeps running until a certain condition is false. Yeah, so it kind of tests this condition continually, loop after loop, until it evaluates to false, then it breaks the loop. Okay, so now to demonstrate that very well, I'm going to initialize a variable called apples, and I'm going to say I have 4 of them. Okay, then what I'm going to do is I'm going to use the keyword while, yeah, because this is how we initialize a while loop in Python. And I'm going to say apples is less than maybe 12, let's say. Then what should the loop do if apples are less than 12? Yeah, so you could say print apples, something like this. So I'm going to save this and I'm going to run it. Okay, so what it's doing right here, as you guys can see, it's running an infinite loop, which is not so good in programming. And the reason is apple is assigned to 4, and while apples is less than 4, it's gonna print this out. Yeah, so because it's 4 and it will always be 4, we need a way to kind of play with this value, yeah, and kind of increment it in that this for loop doesn't happen. Okay, so I'm gonna click this button right here to stop the program. And what I'm gonna do, I'm just gonna increment it. Okay, so I'm going to say something like apples plus, hold on, equals 1. Okay, so what we're saying, that's each time we print out apples, okay, we're going to increment it by 1. Yeah, so the first time it's going to run, it's going to be 4, so it prints out this first time. Then we're going to increment it by 1, so then this variable becomes 5. Okay, then it runs again. It's going to do that until this apple is incremented to something like 12, then it will stop the loop. Okay, so let me save this and run it again. Okay, so now it has printed 4, 5, 6, 7, 8, 9, 10, and it stopped on 11. So as soon as it's incremented to 12, then it breaks or stops the program. Okay, so now guys, I want to talk to you about the break and the range keywords that you're gonna encounter very often when you're handling loops. Okay, now let me write down this code so that you guys may clearly understand this. Let's have a random number that is called okay, let it be 15. Yeah, so I'm gonna run a for loop. It's gonna test that for x in a range. What this keyword does is that it inputs or it intakes a certain figure. For example, if I want to start it from 1 to maybe 50, yeah, it's gonna create a range or a series of numbers 1 to 3 up to 50. Then what happens if this x, because it's gonna take x, yeah, for example, let's say it takes 15, and it's gonna examine this range to see if it's in this range of numbers. Okay, then we're gonna write an if statement to say that if, okay, x is equivalent, yeah, to the random number, sorry, I used z, yeah, but it's supposed to be x, is equivalent to the random number, so I'll just say random number, then what should the program do? Then we say we're gonna print out something. For example, print I'm gonna say n, sorry, x comma, then after something like x is is a random number. Okay, is a random number, something like that. All right, then what I'm gonna do, I'm gonna use the break keyword. Let me just put something down here just to cater for the else part. So in the else statement, I'll just say something like print x. Yeah. So what this code, let me zoom out a little. What this code is doing basically is that we initialize a random variable and we assigned it 15. Yeah. So what the loop is gonna do, it's gonna examine for example 1. Yeah. It's gonna run, x is gonna be initialized to 1, which is our first figure in the range. Yeah. So it's gonna examine is 1 equivalent to the random number we're chosen, which is 15. Then it's gonna be no. So what that does, it will just break out of the loop, then it'll just print, you know, figure number 1. Then it goes to number 2. It examines whether the number 2 is equivalent to this random number, the figure that's stored in this variable. Then it's gonna be no. So it will print out 2. Then once it reaches 15, then it will print out x, and it will say x is a random number. Then it will break the loop. Okay, so let's run this and see. Yeah, so as you guys can see, if I'm to zoom out a little bit, is that you're having 1 2 3 4. Once it reaches 14 and encounters 15, it says that x is a random number. I mean 15 was the random number that was chosen. So I'll remove this x, then save it and write it again. Yeah, so say 15 is a random number. Okay, yeah, hopefully that was clear. Let's discuss one more keyword, which is continue, and we proceed. So now let's talk about the continue keyword. I'm gonna take an example. Let's say you have 20 tables in a restaurant. Okay, but you have, for example, taken tables, okay, which is gonna be a list of, let's say, table 2, table 4, table 6. Okay, and what you want to do is to list you want to write a program that's gonna return the list of empty tables. Okay, then maybe you run through a print command or something like print for example, we can say these are the available tables. Okay, yeah, so now we said we have 20 tables, which means we can run a for loop, and we say for n in a range, okay, of, you can use of 1 to 20. 1 initialized at the beginning of the range, then 20 the end or the stoppage of the range. Okay, so once we have initialized the condition for n in range of 1 to 10, 20, table 1 to 20, then you're gonna write an if statement. We say if n is in tables taken, yeah, then what we're gonna do, we are just gonna say continue. All right, then we are gonna print out, I'll just print n. Okay, so let's save this and run this, then we see what I'm doing. So it's a long list right here, but I think let's just make the range to 10, yeah, so that it's more visible. So I'm gonna run it again. Then you see it has printed out table 1, and it skipped 2 because 2 is already available in the taken tables. Then it prints out, it skips 4 because 4 is already available. Then it prints out 5, then 6, 7, 8, and 9. Okay, yeah, to make this more understandable, maybe you say we can put something like table, something like this, then a comma here, We save that. All right. Yeah. So it's that table 1 is available, table 3 is available, table 5. So it skipped the taken tables, then return the values that, I mean the table numbers that are available. Yeah. Hopefully that was clear. So I want to talk to you guys now about functions. And what a function is, it's basically a piece of code that you can create and reuse it over and over again across different sections of your program or even in other programs. Okay. Yeah. Basically, let's write a very simple function, and I'm going to show you guys how to declare them. Okay. Now, to declare a function in Python, you start off with the keyword def, and I think that stands for define. Yeah. So def, then you write the function name. For example, if you're creating one for greeting, maybe say greeting. Yeah. Then after that, you put parentheses like this, then a colon. Yeah. Then once you write that, you hit enter. Yeah, it indents it to a new line, and you're gonna start specifying what this function does. Okay. So now let's say this function is just printing out hello. Let's say hello, how are you doing, something like that. Okay, we save this up and we run it. Okay, and as you guys can see here, it's empty because and the reason why that is empty is because we haven't actually used this function, we have only defined it. Okay, now to call a function, yeah, what that means is to sort of invoke it. Yeah, so you've created the function, but to put it to use, you need to invoke it. Okay, so to call the function, we just say something like greeting. Okay, then we hit save and run it again, and there we have something that is being returned the function by the function. Okay, so it's saying hello, how are you doing? Okay, but what if we wanted, for example, this function to say something like hello Enoch, how are you doing? Yeah, then what we'd do is, let's say we wanted to intake some information, for example someone's name. Okay, then inside this parentheses in the function itself, you'd say something like name. Okay, and at the end of this statement right here, we can pass this variable name that the function receives. Okay, then once we are declaring this function, for example greeting, okay, then we can pass a name to it. For example, let's say Enoch, but this time around we put it in these quotation marks. So we save and run the program. Then it's gonna say hello, how are you doing Enoch? Okay, then you can also pass variables here. For example, let's say we have a student, a variable called student, and in this student we have maybe Alice. Okay, then we can also pass something like student in here. Okay, then if we save and run that, it's gonna say hello, how are you doing Alice? Okay, now let's say this is student maybe 1 instead. Yeah, we save that up, it's still gonna say hello Alice. But let's say we have another student, and maybe we'll call them student 2, and student 2 is Mark. Okay, let's add one more student and say student maybe 3, and student 3 can be David. Okay, yeah, so now what we can do is, this is the importance of functions. Okay, we can say, let's say we write a greeting, we call the greeting function once again, but this time we pass in student 2. Okay, then we call that function again, then we pass in student 3. Okay, if we save this and run it, so we're gonna say it says hello to Alice, which is student 1. Then it says hello again to student 2, which is Mark, and David, who is student 3. Yeah, so it keeps on running, but remember you're passing in different variables, and it's getting that variable right here. Then it's passing it to this print function right here, which prints out these different names. Okay, yeah, so it's useful that it saves some time, because if you wanted to print this out manually, then you'd have to type this function, this code, but outside this function. So it would be sort of repetitive and time consuming and not efficient. Okay, so that's how basic it is. Yeah, but I'm gonna explain more still about functions so that you guys better understand them. Okay, so let's talk about return values, because not all times you're gonna be needing to print this right here. Yeah, you may want to store that variable and sort of use it later in the program. Okay, now let me highlight all this and delete it. So let's say we want to figure out the square of two, for example, of a single number. Yeah, and we are going to define a very custom function. Okay, so we say def to define a function, and we write the name of the function that we want to create. For example, in this case, we're going to find out the square of a number. Then we get, remember, we need this, actually this ain't spelled right. Yeah, let's say for this function, we're going to be taking a number, for example, the number that we want to figure out its square. Okay, then what we're going to do is we're going to initialize a variable right here, for example square. I will say square. Okay, and we are going to assign it the product of this number times this number. Okay, so it's going to be num, the number we get from here, times the number itself. Okay, then we are going to write a return keyword here to return the square. Okay, so basically what this function, when this function is called and it gets, for example, it receives the number like 10, yeah, then what's gonna do at this stage right here, it's gonna multiply 10 by 10, then store this value in this variable sq, and it will return the product of 10 times 10, which will be 100. Okay, let's see how that works out in a practical way. Okay, so now what we're gonna do is gonna call this function or invoke it square, but we need to square 10. Okay, so let's save that up and run it. Okay, and right now we don't see any output in the console, reason being that we haven't called any print function to print actually this square. Okay, so let's store this square in a variable called, let's create one, for example, sq1. Yeah, then we can actually print out that variable. Okay, so it's having some error here, and I think, let's see if you hover over. Yeah, so I think there are some indentation issues, so I'm gonna do this. Yeah, put it on the same line as a define function, as a def keyword. Yeah, then once that's done, let's call the print function, and we just print sq1. Okay, we save that up. Okay, then we just run it. So we passed in 10, so it went to the function, figured out 10 times 10 and stored it up here, then returned it. Okay, so whenever we call, for example, let's say sq, it doesn't have to be sq or something, it can be x. Yeah, then let's say we want to figure out the square of 7. Okay, then once that's done, we can actually print out x, in which the square of 7 is stored. Okay, so you see how the first line prints out 100 for 10, Then for 7, the print x is for the 49. Okay, yeah, hopefully that is clear. Now what we're going to talk about is default values. Then once we talk about the default values, we're going to look at variable scope, then keyword arguments. Okay, let's move on. So now we're going to be talking about default values. Okay, and I'm going to first remove this. Now you see how this function kind of takes in this argument right here. By the way, that's a technical term for all the information that's passed on right here. Yeah, sometimes you may want to set these values initialized to something, which is not always the case, but sometimes comes in very useful. Okay, say we want to create a function that lets us sort of send out a greeting message to someone, or it introduces someone, but we just don't know their age. Okay, let me use a code example that you guys will understand. Yeah, so remember that the way we define a function, we call a function using the def keyword. Let's say our function that's going to introduce someone is called introduce. Okay, and by now you guys already know that we use parentheses to pass in the arguments that we want our function to use. So for example, our function will need a name. Okay, but then let's say we also want to know their age. Yeah, so then we can say age, and we just assume that by default, yeah, everyone's age, for example, at a given party is 18. Yeah, then we use these colons, hit enter, and it goes into the next line. Okay, then you're gonna print something. Yeah, let's print something very simple. And right now I don't think we have talked about formatted strings. Yeah, but what a formatted string is, for example, once I'm at this print function, I can say if. Okay, let me zoom in a little bit that you can see clearly. Yeah, then after here I insert quotation marks. Yeah, and what this tells the program is that someone has inserted an F here, but this following text that's gonna be in between here is a formatted string. Okay, sorry, I'll just undo that. It's a formatted string, so I can say hello, and let me show how formatted strings work. Okay, my name. Okay. I could say hello, then I could say my name. My name is. Okay, now I want to insert this variable here that would have been passed, and to do that I will use these curly braces. Okay, now once this f function is encountered, then it tells the computer this is a formatted string. It's a formatted string, and inside formatted strings you can have these curly braces that act as placeholders for variables. Yeah, so my name gets passed inside there. Okay, and we can say something, and I'll leave a space here, and I am. Okay, then I'm gonna insert another curly brace to cater for the age. All right, 19 years old. Okay, so yeah, if we save this and run it, obviously nothing is going to happen because you haven't called the function. Yeah, so now let's use this function, yeah, by calling it somewhere in the code. Okay, so now I'm going to call introduce, and I'm going to pass in only for example, I'll use Alice. Yeah, then I'm going to call it again, and I'm going to say introduce, and let's say for the first argument the name. Okay, the name right here, I'm gonna pass in Bob, and I'm also gonna pass in maybe Bob is 45. Okay, And if we save this and run it, yep, so it's gonna say, hello, my name is Alice and I am 18 years old. So by default, Alice is 18. Okay, so if we add another name here, for example, paste that in and say Jack. So you're gonna see that Alice right here. I think I'll leave a space here so that everything is readable. So Alice right here is by default, I've given her an age of 18. Jack right here has been given a default value of 18, and Bob right here, it's called overriding. This 45 overrides the 18. Then Bob becomes 45 years old. Okay, so by default values are important. In that sometimes you might want to store this data in the database, yeah, and you don't want to store null values in your database. So it's rather important that you assign default values, yeah, that get printed to the database. Instead of having null values, you rather take a default value, yeah. And you realize that you need to pass in the name, because by default the name is not set to something. Okay, but also the name can be set to a default value. For example, if we assign this to let's say if someone didn't enter a name, yeah, then we just say unknown. Okay, then we can still call the introduce function, and if we run it, yeah, you realize that it printed out the default values. Okay, yeah, so now let's move on to the next module. So let's take a quick look about variable scoping. Okay, it's really important. I'm gonna remove this, and I'll say something. Let's say we have a variable called greeting, and it's saying hello boss, something like that. Then let's say we have a function, for example, we can say define, yeah, we can call this stuff, something like that. Doesn't really matter right now. And what we're gonna do, we're gonna ask it to print out the greeting message. Okay, then we can jump out of that indentation. Then we can call let's call it this CRUD. Still doesn't matter. Okay, then we can ask it to print out the same message, yeah, something like that. Then what we're gonna do is to call this function. So we're gonna call taf, and we're also gonna call GRUD. Okay, and if we save that and run it again, you see that first the taf prints hello boss, then GRUD prints hello boss, yeah. But the way variable scoping works is that this function and this function can access any variable that is initialized outside the function, yeah, outside and above the function. Okay, now because this is outside these two functions, taf can access it and GRUD can also access it. However, if we do something like this, if I cut it from here, then I place it right here. Okay, try to run it again, then you're gonna realize that we are being given some errors right here. Okay, and it's called a name error, greeting is not defined. Okay, and it's on line 8. Yeah, so this function right here is complaining that, hey, I can't access this variable called greeting, help me out. Yeah, yet it was already initialized in this taf right here. So tough is being selfish, and it's hiding this greeting, hello boss. Yeah. So you get the idea. Okay. Yes. Yeah, and this is called a local scope of a variable, so only the function that created it can access it. However, if I'm to remove it here, then this is a global scope of a variable. Okay, yeah, if we save this up, then everything is back and running smoothly. Okay, so now let's talk about actually keyword arguments before we leave functions. Okay, keywords are really cool. Keyword arguments are really cool. I already showed you guys how to pass default values to functions. Yeah, so let's say we have a function that stores student details. Okay, maybe we shall call it student details, something like that. Then it's gonna take in a bunch of default values, for example name. But first I'm gonna make them default. Let me just set name, the grade they're in, and maybe let's say their residence. What else can we store about the student? Actually, let's remove residence. We can use sex and maybe nationality. All right. Then what we're gonna do once this information is passed in, we're just gonna print out the name. Okay, that would have been passed. Then we print out the grade. Okay, then what else are we going to be printing out? The sex and the nationality. Okay, the sex and the nationality. All right, now this function is already looking good, but if we run this function, for example, student details, yep, and we run it, it's gonna give an error, yep, and it's gonna say that it's missing 4 arguments that are required: the name and grade, the sex, and nationality. Okay, so which means we need to insert them. So we can say something like Jack, which is a name. Okay, so he's in grade 12. Then what else can we say? The sex, maybe it's M, and the nationality is from the US. Okay, save that up and run it again. Then Jack 12M is from the US. Okay, based on the point of this module, because right now I just wanted to show you guys how default values are important. Okay, because if someone didn't pass anything here right now, would be getting this error. Yeah, so to kind of overlook that and solve that, maybe we would use default values. Okay, so you do something like already initialize this to set it something like the default name can be Enoch. Okay, or for practicality, okay, let me just use my name. Yeah, Enoch, and we set the grade to something like maybe grade 12. Yeah, grade 12. The sex is M. Then we can also initialize the nationality to be let's equate it to some like Eugene. Okay, but I would like to do this. I wouldn't like to leave any space. Yeah, these tiny errors can make the code so unreadable. Yeah. So now that we've passed in some default values of the name, the grade, the sex, and the nationality, okay, by default, if we save this and run it again, then it's just gonna print out these default values, okay. But there are some instances where you might want to, for example, only pass the name to the function and the grade, and just assume that these can remain as default. Okay, let me show you something. If we call this student details and we just pass the name, for example, if you want to override all these, for example, as we did with Jack, yeah, as we did with Jack, so we say Jack, yeah, but Jack is in grade 7, so the next portion that you're initializing is you're overriding is the grade, so you would insert maybe grade 3, okay, and obviously the sex, it's M. Then lastly, I showed you guys that the country would be US. Okay, so if we save this and run it, obviously it's going to override everything that came by default with the function, yeah, but that may not always be the case, yeah. So let's say you want to skip some arguments, okay, but to do this you would have to pass the name. I mean, you have to use this keyword right here, or this, or this, or this, because once you don't do that, it's just gonna assume that, for example, if you just wanted to pass in, let's say, Alice. Okay, let me show you guys what I really mean. Then you just wanna pass in, Alice and the sex type of female. Okay, you save this and run it, and you see that Alice would have been changed, but then the grade would have been changed to elif, yeah, so the sex stays as M, and the country also remains as default, yeah. So it's changing the wrong place value. Okay, so what we're going to do is you can pass them using keywords. For example, I can say name, and I will assign it to Alice. Okay, then I'll go and I change the sex placeholder to F. Okay, so once I save this and run it, you realize that it went and overrode the name place value for the function, and it also went and changed the sex value, the default value for sex, which is M. Okay, so that's how cool and really important keyword arguments are, and you come across so many functions with over like 10 arguments that it's in taking, but some are already initialized to 0. Okay, it's really important. So guys, sometimes you'll be creating functions, but you may not know before, like how many number of arguments that your function may need to intake. For example, here we have 1, 2, 3, 4 arguments that our function needs to work with, but in some cases that may not be the case. Yeah, for example, if you're building a function that's going to add up some numbers, for example, if you're building a calculator, okay, you may not know how many, sorry about that, you may not know how many numbers someone is going to enter into your program. Yeah, so you may need a way of playing around with that and creating a function that accepts an infinite number of arguments. Yeah, for example, let's say you wanted to build an application or a to-do list app or a shopping list sort of application that kind of adds new products that you need to buy onto a list. Yeah, let me demonstrate something. For example, we can define this function and call it shopping list. shopping list. Yeah. And to tell Python that the function I'm creating is taking an limited number of arguments, we use the star, the star, the asterisk, and we can say something like args. This is a very common keyword that people use a lot in Python, but you can really name it anything. For example, I can name it products. Yeah, and I'll just add a colon right here. Okay, then what we're gonna do is we're gonna create a loop that's gonna add every item that someone adds to that shopping list. For this case, we're just gonna be printing it out. Okay, so we're gonna say for x in products. Okay, why am I saying products? It's because it's this range of values that's gonna be entered. Yeah, be it 5, be it 100 items, be it 60 items, we're just gonna look through them. Okay, because we don't know how many there are. Okay, now what we're gonna say, print, let's print this out, and we could say adding. Okay, we're gonna say x because each item that's gonna be looped through is gonna have be stored in this placeholder x. Okay, so we're gonna say x, then I will just say to the shopping list, to the shopping list. Okay, so I'll remove this space, and function looks clean, but we need to call it, guys. Remember, we need to, I don't know why it's not indenting right. All right, okay, so now let's add some items to the shopping list. For example, if we call the function, okay, then maybe we need to add bread. Then what else? We need to add some meat, and then we need to add some sugar, and let's say we need to add, what else? We can add some salt. Yeah, I think I'll stop there. All right, so let me save this and run it again. Yeah, so at first, when this let me explain everything about these code so that you clearly understand what's going on very well. Maybe you can change this adding to added here. Okay, and we shall save that up and let's run it again. Okay, so what's going on right here? We have a function that is called shopping list. Yeah, and it has this special keyword. Yeah, that starts with an asterisk, then proceeded by this word products. Yeah, so this, as I told you, it's very special syntax that tells the program that this function should accept any number of arguments. Yeah, for our case, we are saying that we can add as many number of products that we wish to add. Yeah, so for example, if I needed to buy some butter, I would still add it to the butter. Is not spelled like that, no way. Yeah, we can add as many arguments as we want to the variable. We can pass as many variables, I mean as many arguments as we want to the function. Okay, so when we call the function, yeah, it goes it stores these values that have been passed into something like a list, yeah, of items. Then once it's stored in this list of items called products, yeah, it uses this x placeholder to loop through at first instance it adds bread, it prints out bread. Then on the second run of the loop it prints out meat, then sugar, then salt. So if we save this up and run it again, because I've added butter to the list, then it adds butter. Okay, yeah, it's very simple but yet useful. All right, so guys, that's all I had for you for functions, but now we need to discuss something else, something about sets. Okay, I'll copy this because I think I'm gonna need it for the next code example. So I'm gonna copy this while I delete this. Okay, so now I want to create a shopping list. For example, I can do something like, call it, come on, if I can only type shopping list. Yes, that looks okay. Then obviously I think, let me just type them in. Let's say I wanna buy some apples, bananas. What's happening to me right now? I want to get some oranges. Okay, and let's say I want to get some bread too, and some salt maybe. Okay, actually let me demonstrate something really important. Let's say we repeat bread right here. Yes, let's repeat bread. Okay, so I'm gonna copy this. So if I save that up, okay, and I try to print it out, for example, if I say print, come on, print shopping list, I'll save that and run it once again. So it's gonna print apples, bananas, oranges, bread, and yeah, everything else. Okay, but now the way sets work, it's kind of different. Yeah, so let me call this maybe groceries. Yeah, groceries. And to create a set, you use these curly braces, then you can paste in the same information. Okay, but if you try to print out, for example, the groceries, yeah, so let's print out the groceries and you guys will see the difference, what I'm talking about. Okay, so you see how bread is repeated twice in the list item. Yeah, the sets can only have unique values. Yeah, so it detects that actually this set has bread repetitively, but it's gonna use only one value. Okay, now to clearly demonstrate the importance of sets, let me show you something. Okay, so what you can actually do is I will remove this line of code and I'll write an if statement that checks whether something is actually in the set. Yeah, so if I can say apples, all right, I'll say apples is in groceries. Okay, then I would print out, you got the apples. I'll print out apples are in the list. All right, and then I'll write an else statement. Then I'll say you forgot the apples. You forgot apples. You forgot the apples. But now this apple had a spelling error. I'll save that and run it once again. Yeah. So right now it's pulling up some error that's saying syntax warning. Is with literal. Did you mean this? No, actually it was supposed to be in. Okay, yeah. Is tries to equate something, yeah, but I'm trying to use in. Yeah. So it's saying, yeah, apples are in the list. Yeah. If I try to add, for example, something like butter, yeah, if I'm trying to check if it's in the glossary set, okay, then it'll say you forgot. Okay, it's saying apples, but I meant to say butter. I think you guys get the idea. All right, you forgot the butter. Okay, yeah, sorry about that. Or let's proceed. All right, and that's how basically the sets work, and I'm gonna show you guys later on um some of the cool stuff that you can do with the sets and the dictionaries. Okay, so let's talk about the dictionaries. Okay, so I'm gonna create another shopping list. Yeah, but right now what we're gonna be having, because initially you'd create something like apples, yeah, in your hold on, sorry about that. I want to insert a comma right here, so you'd have maybe grapes, and you'd have something like oranges, and let's say you have also cherries. All right, so now we have 4 items. Basically this is how a usual set would be looking like. Yeah, but then you can convert it into a dictionary. Yeah, let's say for example we want to add some information of how many apples, grapes, oranges we had. What you do is to insert this colon. Yeah, then for example add 5. Then you can do the same for these. This can be 6, maybe this can be 19 oranges. Then and it doesn't have to be a number, it can be some information. For example, if your cherries are red cherries, you can say red. We got red cherries. We got red cherries. Yeah, something like that. Okay, yeah. But I'm gonna remove this because that's not why. It's on the concept I'm building, but this can be 7. Okay, so basically what's going on right here, the same way a real life dictionary would have a word and its meaning. Yeah, so what we're having right here is called a key value pair. Okay, so we're having a key value, a key which is called a pause, and a value which is 5. We're having another key called grapes, and the value is 6. We're having another key called oranges, and the value is 19. Okay, you get the difference. Okay, now let's say we wanted to create a loop that's gonna loop through all these items and print out, for example, we have 5 apples, we have 6 grapes, yeah, something like that. Okay, we can create a for loop. Yeah, remember about how in case we wanted to loop through something, we would say for I in, for example, shopping. If this was our list, yeah, we could do that, and to iterate, yeah, to use this I to iterate through, to loop through each item in the shopping list. However, we can do something really much more cool than that. We can use some syntax, for example, K and comma V, and this is a very common syntax when someone is looping through a dictionary. Yeah, and it doesn't always have to be K. It can be U, it can be T, it can be Y, it can even be a word, for example E or D, something like that. Yeah, but what I'm saying is that it's common practice to find that most programmers are using K to stand for the key, then V to stand for the value, whatever is on the right hand side. Okay, so we're saying for each key and the value in let's say shopping, which is our dictionary. Yeah, so we're going to try to retrieve the items in the shopping list. Yeah, so it's going to retrieve the items. So what this items method does, okay, what it does is that it gets both the key, yeah, which is apples, and also the value, which is 5, from this dictionary at each iteration. Yeah, so at the first iteration it goes this statement right here. It picks apples and this value of 5. Then on second iteration it goes and picks these key groups and the value 6. Yeah, I think you get the idea right now. Okay, so what we're going to be doing is that we're going to print out some stuff. Yeah, so we're going to use a formatted string, as you guys remember. Yeah, then what you're going to do is we have, and the reason we use formatted strings that we want to use is curly braces, and we print out, for example, the first thing we're going to print out, because we want to save 5 apples, we're going to print out the value, which is on the right. Yeah, then the key can come later. Okay, so we can also add it right here, and we can add the key. Yeah, so remember, k is a place value for the keys, and v is a place value for the value at each iteration. Okay, if I'm to save this and run it once again, so I'll leave a space right here. Yeah, just so everything is readable. So it says we have 5 apples. So at the first iteration, it gets the value and prints out the key, its respective key. Then we have 6 apples, and so on. Okay, so I think that was kind of easy to understand and also easy to explain for me. Let's move forward. Okay, so now guys, I wanna talk to you about what's called modules in Python. Yeah, and the way a module works, take an example. Sometimes you may have some pieces of code, for example, like user authentication, let's say adding a new user to the database, and maybe logging in for whatever problem case you may be solving. And sometimes you might have some function that you write and you really wanna reuse them a lot. Sometimes they are called modules, but yeah, for simplicity, I'll call them function. Yeah. So to do that, we're gonna create something, a new file, a new Python file, and we are gonna call this maybe growth. Yeah, just randomly. Growth. Yeah. And in this Python file, I'm gonna define a function, and I'm gonna call it def. Yeah. Maybe login, something like that. Then obviously I'm not gonna be taking an argument right now, but what I'm gonna do, I'm gonna print out something, and I'll say print you are successfully logged in. You successfully logged in. All right, I'll correct this. I think, I don't know if that's right, but I'll leave it at that. All right, so I'm gonna save these. Okay, now I always like to use lowercase functions, yeah, which I think is really good. Okay, so now that has been created. Okay, so now to import this function in this program, because it's a program that I want to import it in. Yeah, so I would write the keyword import. Okay, and you're gonna meet this a lot. Yeah, you will hardly build any large scale Python programs without using these modules. Okay, so you're gonna say import. Yeah, And after typing this keyword import, you need to specify the file name that you want to import. For example, I want to import GRUD. Okay, and that is important. Okay, now just because we have imported, for example, if you run this program right now, it literally says nothing right here because we haven't called any functions from the GRUD Python file. Okay, so now what we can call is this function. For example, we can say login. All right, and specify that, save it and run it. And right now it's gonna say that login is not defined. Okay, and the reason it's saying that is because it can't identify um which module this login is specified or is written. Yeah, so let me copy this, and I'll copy this text, then I'll create a new Python file. Maybe this would be tough. Yeah, then I'll just paste in. So maybe I'll say you successfully logged in. Then I'll print out something else, like print this. This is from the tough. Okay, the tough module. All right. So I'll copy this and I'll go to the GRUD module or Python file, and I would say this is from the GRUD. Okay, yeah, and I will save that, and I will save these. So I'll come back to these. Remember, I was still explaining that it can't really identify which function, because now look, we are having login in GRUD and we are having login in TAF. Okay, and if I'm to import TAF, okay, if I'm to import TAF right here, it still won't be able to tell, yeah, whether this function is declared or it should use this function from GRUD, or it should use the function from TAF. Okay, so to specify what function from which module it should use, you can specify something like GRUD dot login. Okay, hold on, I use the comma instead. I'm still using comma instead. Okay, so right now, if I'm to save that and run it again, so it's going to say you're successfully logged in. This is from the GRUD module. Okay, so if I want to call this function from the TAF module, then I would have to change this to TAF. Okay, then it's gonna print out the same thing, or otherwise I can still use the GRUD, and I'll say dot login. Yeah, so I run this and it shows you the different modules that the function is being called in. Yeah, so basically this dot operator tells the program, okay, go into the TAF module, pick a function called login and run it. Okay, simple as that. And we're going to be looking at classes to understand more concepts of how these things really work. Okay, let's proceed. So guys, I want to talk to you something cool about classes. And in Python programming, classes are used so widely, a lot, because it's a form of practice that is used in programming, whereby you collect a group of related functions and kind of store them or code them in a class. Yeah. For example, if you had some authentication classes, yeah, so you'd write a class that authenticates a user, you'd write a class that authenticates that handles, and in that class, sorry, they would have some functions, and in that class would be some functions that authenticate a user, they authenticate a subscriber, they authenticate an admin, stuff like that. Yeah, so let's say you're creating an e-commerce website, you'd have a class that sort of handles creating a product, how it's added to the database, how it's removed, and all that stuff. Yeah. So under that class, for example, you'd have a function that adds a product. You'd have a function that removes a product. You'd have a function that kind of edits the product details and all that stuff. Yeah. Now we're gonna use a very simple example. Yeah. And to declare a class, for example, you can declare a class maybe that's gonna handle student details. Okay. So it's gonna be, I usually like to name them, and the standard practice to use capital letters when you're naming classes. Yeah, just so it differentiates them from the variables and the functions, the way they're named. Okay. Now, by default, it's important to have something like a constructor. Yeah. Now, I'm gonna talk about that, so you don't really need to get scared what that means. But let me try to write some simple code here, then so that you understand the concept. Then we make it more practical. Okay. All right. Because by default, all classes have what they call a constructor, and it looks something like this. Even though you don't declare it, it's just embedded in there. Yeah. So it's an underscore. Yeah. Then in it, then okay, I typed int, but it's supposed to be nit. Yeah, something like this. Then self. Okay. So this is like the default action of what the class does. Yeah. Once it gets called, like this is the default sort of command, or in case you're having variables that you're passing or arguments, it's a default action that the class takes. And I'm gonna show you guys how it really works. Okay. So we can see something like print, something like some just random text. Yeah, I really couldn't think of something. Yeah. And inside this class you're going to create some functions. Let me just create one function actually. Def I'll call it create, and to have that self, and I'm going to explain what self does. Yeah. So, and we're going to say print I am awesome, something like that. Okay. Now you guys see this indentation, so we declare the class, so everything is in that is indented along this line. It's basically telling the computer that it's under the class student. Okay. So now we need to jump out of that indentation and come back here. Then we're going to create something like a variable. Let's say we want to use functions in this class, or we want to make an object of this class. Yeah. So probably at this stage, let me introduce the concept of objects. Yeah. Now an object is basically okay. So an object is think of it as something a little object. For example, if I created an object called Groot, yeah, but I want it to inherit some properties of a student. Okay. Or let me just use a name, for example, Alice. Yeah. And this Alice object inherits all the properties called student. Yeah. So for example, if we had a variable called name, yeah, then we assign it something like Ruth. Okay. And we had grade, and we assigned it 7. Yeah. So when we create an object called Alice, yeah, what it's gonna do, it's gonna inherit, yeah, or make a copy, sort of inherit other variables, these, then all these function to itself so that it can manipulate it. Yeah. And you're gonna see this very much often in programming. Yeah. So let's create an object of the student class, and to create an object of the student class, we just have to call it like that. Okay. So we have Alice, let me zoom out just a little bit. The Alice object that is instantiating a class student. Yeah. So this line of code is basically telling the compiler or the program, get all the functions, get all the variables and all the methods inside here, and make them accessible to this variable right here. Okay. So once it's given access to all these, yeah, to all these functions right here in this class, okay, then it becomes an object. Yes, it is only to be a variable. Okay. Yeah, because someone can look at this and they think, oh, that's just a simple variable. The same way you assign Alice to something like she has long hair. Yeah, this is an object by itself, but it's just a variable. Yeah, data type of string. Yeah, so I don't want to get you too confused, but remember this is inheriting the variables and the functions. Okay. Now to use this function, yeah, what would say is that we're gonna call Alice, yeah, dot, remember it has inherited this function, yeah, so we're gonna say dot greet. All right, and once we save that and run the file, then it's gonna print out a mouse arm. But what this constructor has done, this default init method has done, remember we created it, but it's important that you create one. Yeah. Yeah, it automatically displays this because it has not been called. Okay, it has not been called, but just because it's a default action that a class actually does when you declare the init function, yeah, this is also called. Yeah, but sometimes it's desirable and sometimes it's not desirable. Okay, now let's take a look at a more practical example. For example, we're having I'll delete all these. All right, I'll delete all these. Okay, now let's say we want to store some student details. Okay, in our program or send it to the database. Okay, by default, what we need from a student is their name and their grade. Okay, so it's important that every time someone wants to add a record to the database, yeah, they have the student name, for example, and their grade. Okay, yeah. Now this self keyword is gonna be important because I'm gonna show you guys in a few what that does. Okay, so let's say we pass, it needs the name, yeah, and the grade, just as we've said that for someone to add details to the database, someone needs to have a name and a grade. Yeah, otherwise this function shouldn't work. Okay, now when you try to say that the name, okay, that is being passed by the calling function should be assigned to name, yeah, okay, then it would be problematic in a way. So it's important to say that to use a self keyword, yeah, to refer to self dot name, yeah, because now when the name is being passed on, yeah, what the self dot name is doing is that it's actually assigning it to this variable or argument right here. Okay, maybe you understand it better. Let me just complete this code. Okay, so we're gonna say self dot grade, and we assign it to grade. Okay, and now we're gonna write the custom function that we want to use. Okay, so the define, we're going to say introduce, and we're gonna say self. All right, okay, the keyword was already passed in there. and we're gonna print out let's just print out, I think, self. All right, self dot name, come on, and self dot grade. All right, so now I showed you guys how to create an instance of the student class. Yeah, so to create an instance means to create an object. Okay, so what we're gonna do is we're gonna say student. We're gonna create um, an object called student1, and what we're gonna do is we're gonna assign it to, we're gonna create an object of student of the student class. Yeah, and for this student we're gonna say maybe Alice. Okay, right here the name to that student, then we're gonna also pass the grade, which is, let's say she's in grade 4, grade 6. Okay, yeah, and let's say we have another student, so it's a student, we shall say student 2, then create another object of student, and let's say we have Mark here, and it's in grade 8. Yeah, that's good enough. Yeah, so now let's call this method right here. Okay, I think they should be introduced. Yeah, and we're gonna say student1 dot introduce. Okay, then student2 still introduce. All right, so let's save that up and we run it. Yeah, so it prints out that Alice grade 6, then Mark is in grade 8. Okay, now to go all over it again and explain everything bit by bit. Okay, we created, firstly, so now let me explain. We obviously we created a class called student. Yeah, and this class has two attributes. Yeah, remember we need the name and the grade of the student. Okay, those are the properties that a student has. Yeah, then the init method sets the name and the grade attributes, the initial values, like when every time an object is created. Yeah, so what that means, yeah, when hold on, remember, like when a new instance of the class is created, yeah, what this init method does is to get this name and the grade, which is Alice and and grade 6, and gets those respective values and assigns those values, the name and the grade, into their respective variables. Okay, it's important that the constructor does that, because remember, you don't call this function, but it's invoked every time a student object is created. Yeah, so whenever these values are passed, yeah, then they get assigned by default to this variable and this variable respectively. Yeah, so that's where the keyword self comes in. Yeah, is that get this whenever this function is called, I mean whenever a new object is called, get this Alice variable itself and assign it to itself. Yeah, I don't know if I make much sense. Yeah, but there you have it. Then we're also having the function called introduce, that, you know, I just named this introduce, but basically I just wanted to print out the name and the grade. Okay, then we created two instances. This is instance 1, then this is instance 2. Okay, so we can reuse these classes differently, and this does not affect this class or this class in any way. It's just sort of a template that we're gonna always keep on reusing. Okay, yeah, hopefully that made some sense. So now, while we're still here, let me talk you about class variables. Maybe you get a hang of classes more clearly. So let's declare a class called girl, maybe, and what we're gonna do is that maybe by default all girls are female. Yeah, so I'm gonna say gender, and I'm gonna assign it to female. All right, and this is what's called a class variable. Okay, and you guys are gonna see it in action shortly. Okay, so then we're gonna define an init method. Yeah, so you guys remember that an init method is defined, or it's invoked every time a function is called, whether there are no custom functions in the class itself, or in case you don't write any, by default it's there. Okay, so now we're going to use the underscore and call this init function. Yeah, and write some code in it. Okay, so I want to pass a variable called name. Okay, to this init method, and I'm gonna call the self keyword and name. And what's basically this line of code says is that whatever name attribute or value is passed to this class, yeah, or to this method. Remember, you can pass variables to a class. Just get that value, just get that name, and store it into name. Okay, so now let's create some objects of this class. Yeah, so for example, we can say our girl1, and we can create an object of the girl class. Yeah, then what we're gonna pass inside there is a variable, but this time it's gonna be a girl's name, so she can be Jen. Yep, then we can create a girl2 variable, I mean instance, I mean object. Okay, girl, then it can be, what girl's name can I use? Alex. Yeah, so there is that. Okay, and if you save this and run this, obviously it's not gonna print out any code because I haven't written any code to print out anything, but let's write some code to print out something. Okay, so so you have two variables. Yeah, so you have this variable and you have this variable. Okay, now I've created two objects. Remember, once you create an object, it inherits everything from this class. Yeah, so it inherits the gender, it inherits the name variables, and also any other method that you'd have here. Okay, so now let's try to print out the gender. Okay, so we're gonna print let's say girl1 dot name. All right, then save that, and the girl1 dot name is Jen, but we can also print I'll copy this, then I'll paste it in, but let's try to access this attribute right here. Okay, and we can say girl1 dot gender. Okay, oh crap, I'll save this and run it. Then it's female. Okay, so I would like to copy this, then I change the same information but for girl2. All right, so I'll remove this, and I'll change this to girl2. Then you'll have that both girls are female. Yeah, because this is a class variable, it doesn't get changed by by this object right here, whereas this is an instance variable. It's created when the class is being called and the variable name is being passed to the class. Okay, hope that makes sense. Now we're gonna be looking at inheritance. Yeah, just more to stress what can be accessed at what level between different classes. Okay, yeah, so let's move on. Yeah, and we talk about inheritance. All right, so I want to still talk about inheritance. Yeah, and it's a very widely used concept in programming. Yeah, okay, so the way inheritance works, the same way the word means, that you get stuff and inherit it from the other. Obviously, the way genetics work, you inherit DNAs and everything like from your parents. Yeah, you can also inherit properties. So the same concept applies in Python programming. Yeah. So I'm gonna create a class. For example, I'm gonna create a class called let's just create a class called parent. Yeah, with those curly braces. Yeah, and what we're gonna be doing is that we're gonna be printing, for example, someone's parent's name. Let's say define. So we're creating a function. It's going to be print parent, something like that. Then it's gonna have obviously that self keyword. Then let's say the parent's name is Marco, something like that. All right, it's Marco. All right, so let's jump out of this indentation and go back to this same line right here. And to create a child class that inherits from the parent class, all you have to do is to write another class as though you declare another class. You can name it anything, but for simplicity purposes, I'll call it child. Yeah. Now, to inherit from another parent class, you just have to type in the name of the class that's actually the parent that you want to inherit from. Yeah. So this statement right here is telling create from a child class. Yeah. But then go to the parent class, a function, a class called parent, then inherit all the functions and the variables and everything in that class, and make it accessible to this class, the child class. Okay, so then let's say the child, you want to print out the child's name, so you'd say def print child. Yeah, run over type. Then what we can say is, for example, we can print out that the child name is Greg. All right, so let's call these classes. Let's create some objects and initialize these classes. Okay, so we're gonna create an object, maybe we're gonna call it name, and it's gonna be an object of the child class, the class we name child. And to create an object, you don't forget these parentheses. All right. So now all this has been, we've created an object of this class right here. So then we're gonna call this function of print child. All right. So let's say name dot print child. All right. So if we save that up and we run it, then we get to print Greg. Yeah. So now we haven't created an object to access the parent class, but since this child class is already inheriting stuff from the parent class, that makes it accessible for us to access this print parent function. Okay. And to do that, we just have to call, for example, name Remember, we created only the object for the child class, but this class is already inheriting stuff from this parent class. Okay, so we can access print parent, and it's being actually displayed right here. Yeah, if it wasn't accessible, then it wouldn't have been visible right here. Okay, so for example, if I remove this, yeah, then I try to type name dot print, it's only showing print child. Okay, yeah, so let's just undo just a little bit. Parent is back in, so in case you're typing print parent, it will just show up because it has inherited that function too from that class. Okay, so it's going to print Greg and Marco. Okay, yeah, basically that's how inheritance works. And there is another thing that you can do. It's called overriding parents. I mean, methods that you've inherited. In larger scale programs and libraries, you might get some access to classes, but the pre-made or default functions, you might want to sort of manipulate them. Yeah, that's why inheritance is important. Okay, so to override a method, for example, you want to change this name, yeah, or there's a lot of stuff going on, or you want to add something, what you do is you come under the child class where you're working from, then you define this function, but make sure you create a function that is similar to this name exactly. Yeah, so what we can do, I think I'll go to the next line. We can define print parent. Yep. Then what we're going to do, what we're doing right now is actually called overriding. Yeah, as I've just mentioned. So instead of printing Marco, we can actually print something else. Okay, we can print like Fraser, something like that. All right, so let's save that and run it. Okay, so instead of printing Marco, what we did was to override this parent class. I mean, this parent inherited print parent inherited function from the parent class, and we basically manipulated it to do something else. Yeah, so we can say is this method has, I'll say function, this function has been overridden. Yeah, something like that. All right, so instead of actually printing any names, yeah, we're actually printing this custom message. Yeah, so let's talk about multiple inheritance, and I guess we get a very solid hang of classes. So then there's something about multiple inheritance that is really cool. For example, I'll first remove this. Let me see how I can edit this to make it more interesting. I'm not gonna override this. Yeah, so now we have the parent class, the child. Let's create a grandparent class. All right, we can say class grandparent, something like that. I will not use capital letters here, so I would say class grandparent. Okay, so then in this class, what I need to do is to print maybe something like, no, let's not just print anything, but I'll create a function that prints the grandparent's name. Yeah, print granny, something like that. Yeah, it's gonna be printing granny's name, and let it just print it out right now. Yeah, so we can call granny, maybe grandma's called Becky, something like that. Okay, so now we have one class, two classes, three classes. But what we can do is that, let's say all these have a grandchild. I'm so tired of creating classes like this. All right, but let's create class class grandchild. Yeah, so the child and grandchild. All right. And this is gonna take in a couple of I don't know if you guys can see it clearly, but I think I'll zoom in because I still remember the code in my head. Yeah, but it's gonna inherit. Remember how the child only inherited from the parent? Yeah, so but I need the grandchild to inherit from the grandparent and her mother, probably. Yeah, so we can say that, okay, inherit from grandparent, all right, then also inherit from the child, all right, we can say child, okay. Now obviously we need the colon right here, and we're gonna press enter, okay. And I think you guys can see this red line, but I don't need to do anything with this class. Yeah, so remember, you can create classes, but these classes can be empty. They may not have any methods in them. Yeah, so if you want to create an empty class, yeah, you can say something like pass, yeah, to tell the computer that do nothing with this class. Yeah, it's just there to inherit some methods and some properties and attributes. Okay, so now let's try and use this class. All right, so we're gonna create for example, I want to use a very simple, let's say Groot is a grandchild. All right, then we're gonna create an object from this class of grandchild. Yeah, so we would say grandchild, and that's how we've created our object. Now what I'm trying to demonstrate here, that this grandchild is inheriting from the grandparent, but it's also inheriting from the child. Remember, the child is also inheriting from the parent. Yeah, sounds sort of confusing, but if you really think about it, it makes some sense. Okay, so let's try to access this method, and this method. All right, so we are gonna say Groot. So you're gonna print Groot's grandparent, grandnanny, something like that. Granny. All right, so we can access a print child. We can access we can say Groot. Oh god, Groot. So I'm sure we can access the print parent. Yeah, then do I need to print parent? Yes, it's over right here. Print child, and let's print the granny. All right, Groot dot print granny. Sounds cool. Save that up and run it, and we see that it went to the print child, inherited this method, so it can actually run it. Still with the print parent, so it got access to print parent through the print child and got access to this. Then print granny obviously directly inherited it from right here, yeah, to access this method. All right, so in larger complex programs, you may get a lot of inheritances and stuff being inherited from here. So you may spend a while debugging if code is poorly written. And that's how experienced programmers or guys who like to keep their stuff complex do it. Yeah, inheriting stuff and abstracting it from here and there. But it's really not a big fuss once you get a hang of it, like the way you guys are by now. Yeah, it's really a simple thing to like sort of figure out. Okay, yeah. I want to look at exception handling, and I think we would be done with this tutorial. Okay, let's take a look at exception handling. Okay, so now exception handling. Exception handling is really important. to prevent your programs from crashing. And almost every programming language has some exception handling functions and whatever's concept embedded into it. Okay. Now, let me talk to you guys about. Hold on. Yep. Okay. Sorry about that. For example, if let me write a piece of code right here so that you guys realize what I'm talking about. Okay. So let's say we have a variable called age, and we want the user to enter their age. So something like, if we ask them like what is, or not even what is, just enter your age. Yeah, I don't have time to wait. Okay. All right. So if it is something like enter your age, yeah, then we just print age. Okay. Then we save this and run it. Yeah. So then it's gonna ask me, let's say enter, I'm 98 years old. All right. Then it's gonna print out 98. Yeah. But there are times when someone is, for example, if I run it again and I type in something because I'm a moron and I just enter this, it will still return this. Okay. Then there are instances where you want, for example, if you're developing, let's say, a calculator, and it would say maybe enter your favorite number, your favorite number, something like that. Then obviously, can we change this to number, or it doesn't matter? Let's just say X. All right. Then we just say X. Yeah. Then we run that. We enter our favorite number, and to make sure that the user enters a number, for example, if you want to add it to something, yeah, we're gonna convert it into an integer. All right, it's not working the way I want it to, but yes, and now it's better. So I'm gonna come on, yes, an integer. All right. So what this does, it's by default any input that's being gotten from the user by typing, it's stored as a string. Yeah. So you may need to convert it into an integer for you to do some addition and multiplication on it. All right. So that's out of the way. Okay. So let's run this. Then what we're gonna do is we're gonna enter, for example, 78. Yeah. Then it's gonna return 78. Okay. But if we run it, yeah, then type in something so dumb, it's gonna bring a value error. Now, a value error is a type of exception. Yeah. So it's saying invalid literal for integer with base 10, blah 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 blah. So basically it's struggling to convert this weird text right here, or the text as highlighted right here, from string to integer. Okay. So you may need ways to prevent this from happening, and I'm going to show you how to do that. Okay. But this is just one type of error. Then there's so many exception types of errors. If I'm to open up, okay, I want to open up Google to show you the types of errors, but that would be so time consuming. You'd have to show you how everything works. Okay, but let me just show you one syntax error. For example, something like this. Yeah, if I saved up this program and run it, it's gonna say syntax error, invalid syntax. Then these arrows will point exactly where the syntax error is. Yeah, be like, so correct something here and you fix it. All right. So even if you're to do something like it and save it up and run it, still where the error is, it will show you that it is not defined. Did you mean ID? Yeah, to try to help you figure out your errors. But so there you have it. Okay, but some are syntax, some are logical, and some are exceptional. Yeah, so you need to a way to catch these exception errors and handle them to prevent your programs from crashing. Okay, so to fix it, there's what is called a try and except set kind of block. Yeah, and this is, I've seen it in PHP, I've seen it in Java, and it's almost handled the same way. Okay, so use the keyword try. Okay, then in this try, yeah, you get, for example, I'm gonna cut this and I'll paste it in right here. All right, okay, then we're gonna print out X. Yeah, so it's still the same piece of code. We're asking someone to enter their favorite number. We are converting it into an integer, yeah, to make sure that it's an integer. Then we're storing it in a variable called X. Okay, now after we try this, you're gonna run another block called except. Okay, now what this except does, yeah, in some languages they use the word catch. Yeah, so you try this. Yeah, if it brings up an error, then you catch it right here. Yeah, so if I had a name error, yeah, I would try to catch it. For example, if it was something like this and I was having a name error, I would try to catch it differently. But now we are trying to handle users who enter strings instead of numbers. Okay, so and the last time we ran this code, it gave us, let me just cut this out and I show you guys exactly what I mean. So yeah, okay, I think I'll just undo this. Okay, it's taking its time. All right, so I'll save this and run it again. Let's say someone enters a name instead. Yeah, then it's gonna bring up this value error. Okay, now to solve this problem is where they try, okay, and catch block come in. Yeah, so I'm gonna copy this code right here and I'm gonna place it in the try code block. Okay, and once I'm done placing it there, then in case someone tries to enter a string, I'm gonna catch the value error. All right, okay, then once I catch this error, I need to say something. I need to run some code. Okay, what happens if someone types a string? Then I'm gonna tell them print. Oh, I have to correct that. So it's gonna be print. I'm gonna say them enter. I wanna say please enter number, you moron. Please enter a valid number. All right, save this up and let's run the code once again. So let's say they enter, for example, 67. Maybe that's a favorite number, but by mistake then they enter u with it. Yeah, then it's gonna say invalid row with base 1067u. Where is the problem coming from? We still have this code right here, and let's remove it. All right, okay, so let's save that again and run it. So let's say they enter 67u. We're gonna ask him please enter valid number. Yum, and obviously the program executes. The program sort of ends. We tell them to enter a valid number, but it shouldn't be this way. Yeah. what we should do is to all right, I think you can stop there. Maybe you can tell them run the program again. Run maybe you can say did not enter. I don't want to make it a loop because the code structure then it's gonna come so complex. Yeah, you entered a string. Yeah, so something like that. Yeah, so obviously if it's 89, then it's gonna return 89 and the program will end. Okay, so there are many types of errors. For example, let's say you wanted to divide, for example, okay, let me just remove this. Maybe you guys will better understand what's happening to this keyboard. All right, we're gonna say except, then oh, let's see if these. All right, so there's a list of built-in errors that can be caught. For example, zero by division error. You can catch an environment error, an overflow error. But usually when you're getting input and you want to convert it to something else, yeah, then this value error, it's one of the most common errors that you're going to be handling. Okay, can I go over the code again? Okay, so we have a try block and the except block, and what this code is doing right here, it inputs a number, prints out this text and gives a prompt to the user to enter their favorite number, and it converts it into an integer, stores it into a variable x. Okay, then it prints out this number right here. Okay, then it tries, obviously what this section is doing, it's just basically trying to run this code. It attempts to execute this code. Yeah, if it fails, then it prints it out. Yeah, that's the basic explanation. Yeah, so if a user enters something that cannot be converted to an integer, then a value error is raised, as you guys saw earlier. Yeah, so to handle the value error, to prevent the program from actually crashing, yeah, you may want to use the except keyword, yeah, to catch the value error. All right, because if this wasn't there, then the program will just crash. All right, now that has been all for this tutorial. The fundamentals I've really shared have been beginner friendly and basic. I'm hoping that I'll be creating some projects as regards Python. I really wanted to put out this concept earlier so that when we start developing web development projects, handling the back end, and you guys are not seeing something new. Okay, so thanks for watching, guys. Please leave a subscription and I'll catch you in the next tutorial.